Welcome to our discussion of the reaction quotient Q. In this video, we will define Q, write expressions for reactions not in equilibrium, and interpret Q by relating it to KEQ. So the reaction quotient, or Q, expresses the relative ratio of products to reactants at a given instant, not at equilibrium. As we've seen previously, the ratio of products to reactants at equilibrium is expressed by KEQ. So our formula, or how we write Q, is actually exactly the same as how we write our expression for KEQ. So Q equals our concentration of products over reactants, the same as KEQ. If you have any solids or liquids, they're going to equal 1, so leave them out of your equation. So you're only going to include those compounds who are in a gaseous or aqueous state. Again, the key difference between Q and KEQ is that these concentrations for products and reactants are not at equilibrium when calculating for Q. So once we've calculated Q and K, we can actually compare them to each other to determine which way a reaction will proceed to reach equilibrium, either towards the products, meaning that it'll make more products to reach equilibrium, or towards the reactants, meaning that it will make more reactants to reach equilibrium. So if our Q value is equal to K, the system is already at equilibrium, so there is no shift. And remember, when we're calculating Q, we often don't know whether or not the system is at equilibrium. For K, when we calculate K, we have to have the system at equilibrium. So if Q is less than K, then we have more reactants than products, so the reaction is going to shift to the right to reach equilibrium. Or if Q is greater than K, then we have more products than reactants, so the reaction is going to shift to the left to reach equilibrium. A helpful way to remember which way a reaction is going to shift when comparing Q to K is to remember to follow the shark. However, in order for this strategy to work, Q must be written before K. So if Q is less than K, we're going to draw a little shark head. There's its eyes and its teeth and its gills on our less than symbol, and we're going to follow the direction that the shark chomps. So in this case, the shark is chomping from left to right. So this tells us, remembering to follow the shark, that if Q is less than K, then our reaction is going to shift to the right. It's going to favor the forward reaction. So at the moment Q was calculated, there must have been more reactants than products. So we can employ the same strategy when Q is greater than K. So again, make our shark, our eyes, our teeth, our gills, and in this case, our shark is chomping from right to left, so our reaction is going to shift to the left, meaning that the reverse reaction is favored, and at the time Q was calculated, there were more products than reactants. So let's take a look at an example. For the reaction below, KEQ equals 5.10 at 527 degrees Celsius. If the concentration of carbon monoxide is 0.15 molar, the concentration of water is 0.25 molar, the concentration of hydrogen gas is 0.42 molar, and the concentration of carbon dioxide is 0.37 molar, calculate Q and determine how the reaction will proceed. Well, as usual, the first thing to do is take a look at our states and make sure that everything is either gaseous or aqueous, which it is. So we're going to include everything into our reaction quotient expression, our Q expression. Then once we have that written, we can plug in all of our concentrations so that we can calculate the final Q value. And remember, just like KEQ, Q is also a ratio, so there's no units for this value. So the last part of the question asks us to determine how the reaction will proceed. So we have to compare our Q to our K. And again, we'll use the follow the shark method. So our Q has to be on the left and our K value on the right. So when we compare our Q to our K, we notice that K is larger than Q, so our shark is shifting to the right. So this means our reaction is going to shift to the right and favor the forward reaction to reach equilibrium. And this concludes our discussion of the reaction quotient Q. Bring any questions you have with you to class.